All right, this is going to be a bunch of algebra. First, we'll do the physics. So the conservation of momentum goes like this. Wait, like this. We have before and after. We have the freight car and we have the caboose, right? So before the collision, the caboose has no momentum, but the freight car has momentum. I'm going to call that mass of the freight car, velocity number 1. After the collision, they couple together, which means they have the same velocity. So we have mass of the freight car, velocity number 2, mass of the caboose, velocity number 2. So this tells us that mf v1 is going to be equal to mf plus mc v2. All right, but that's not enough to get us the answer. So we have to use the fact that they told us how much of the kinetic energy was lost. So before, the kinetic energy, which I could call kinetic energy number 1, was equal to 1/2 mass of the freight car times v1 squared. That was the total amount of kinetic energy. But now we're going to lose some. So we're going to lose a certain fraction, which I'm going to call Q. In my version of the problem, it says 27.1%. So I'm thinking that Q is 0.271. But you use your numbers, okay? So we're going to lose a certain percentage of it. So that means that afterwards, the amount of kinetic energy we're going to have left is going to be equal to what we had before minus Q times what we had before, which is the initial one times 1 minus Q. That's kinetic energy number 2. But there's another way to state kinetic energy number 2. If we look at the after part of the momentum chart, we see that the kinetic energy after the collision is going to be given by 1/2 mf plus mc, the total mass, times the final velocity squared. And since that's the same as this, we can set these two things equal to each other. 1/2 mf v1 squared times 1 minus q. So the first thing I notice is that the 1/2s can go away. But then I'm going to have to do some substitution to get rid of some of this velocity mess. So I go back over here and I notice that velocity number 2 is mass of the freight car times velocity number 1 divided by the total mass. I'm going to plug this in here and get this. mf plus mc, that's this part, times this quantity squared, because that's squared, is equal to mf v1 squared times 1 minus q. Now, can you see that this velocity 1 squared and this velocity 1 squared are going to cancel each other out? Also, one of these is going to cancel with this one. And that will just leave us an mf squared on the top, 1 mf plus mc on the bottom, equal to mf times 1 minus q. And now the mf's are going to cancel out, and all I have is this, the freight car mass, the total mass, and 1 minus q. Now I've got it into things that I know what they are. But I'm going to rearrange a little bit because I like algebra. So I'm going to multiply both sides by this denominator here, giving me mf equals 1 minus q times mf plus mc. So that's, if I distribute carefully, we have 1 minus q times mf plus 1 minus q times mc. I'm trying to isolate the mass of the caboose because I know the mass of the freight car. So that tells me that 1 minus q times mass of the caboose is equal to mass of the freight car minus 1 minus q mass of the freight car. And I think when you mush that around a little bit, you find out that the mass of the caboose is equal to q times mass of the freight car divided by 1 minus q. And remember, q is just this percentage thing converted to decimal.